Proposition 5, Book 2, Euclid. Given a straight line to be cut in even and uneven part, the rectangle contained by the uneven part plus the square that is in between the points of section, the line in between the points of section, are going to be equal, those are going to be equal to the square on the even side. Okay? So here we would have a given straight line, and it would be cut into even parts and uneven parts. Okay? The rectangle contained by the uneven parts, that is just these and these uneven parts, plus the square that is in between the points of section, that would be this one, the line that is in between the points of section. This is square plus this rectangle contained by the uneven parts. They are going to be equal to the square on the even side, this one. Okay, so let's use this color line in order for us to understand better the steps. Okay, so let's get started then. The first thing here we are going to do is to make a line here, and in this line we are going to make a right angle. So here we're going to have a right angle. Okay, we're going to make a line, but we are going to have a right angle. Because why? Because we want to make a square. We want to make a square, and we know that we need to have a right angle when we want a square always. So also we are going to also do this here, and we're going to have here two right angles. Okay, we're going to have here two right angles, and we are going to connect the 2 points. Okay, let's connect the 2 points. Well, so what do we have? We have that this is a square because we did these two lines. The 2 lines are parallel, and we did the angles. We did right angles, so we're going to have a square over here. Okay, great. What do we have? What are we going to do then? We are going to make the diagonal of our square, because this is a square. We're going to make here the diagonal. Okay, this is a square, but this is a parallelogram. Okay, in itself it is a parallelogram. We can say that this is a square. Why? Because we have parallel sides. Okay, we have parallel sides, and we have the right angles, and we need that for a square. Okay, so we are going to have our diagonal. Okay, fine. What are we going to do then? We are going to make here a line from one point, not on these lines. We are going to make a line parallel to both. Okay, we are going to make here a line parallel to this one and make a line parallel to this one. And we are going to have something like these. Something like these. Maybe, I don't know. I'm sorry. Okay, something like this. Yeah. This one is parallel to this one, and this one is parallel to this one. Okay, fine. So what are we going to do then? This one we are going to make from this point, not on this line, a line parallel to it. So we're going to have here this line being parallel to this line, and we are not just going like to do anything without knowing. We are going to just extend this line. We are going to extend this line, and we are going to make these. Okay, we just extended this line, and now we have Yeah, now we have this. I am going to do this one with blue so we can understand better, maybe. Okay. Fine. So what are we going to do here? First of all, we are going to see that we have a parallelogram and that these two are complements, okay? Let's see that they are complements because it's a parallelogram. We have two parallelograms, these are complements. We also know that the complements are equal to each other, okay? And what? Let's prove that these two are squares. We know that they are parallelogram, but let's prove that they are squares. So how are we going to do that? We're going to do that as always, as we had that this was a right angle because we made it a right angle, by the way. So as this is a parallel, as this is a parallelogram, the opposite angles are equal. Sorry. I'm sorry. Forget what I said. We are going to have here two parallels. We're going to have here two parallels, and we are going to have what? A straight line falling upon these two parallels, making angles equal to each other. We are going to have these two angles being equal to each other. This and this one. Okay, I think, no, I'm sorry. This one, I guess, is going to be equal to this one. Because they are going to be, because they are going to be internal ones. Okay, but they are going to be equal. And then we are going to have here also, we are going to have a straight line. We are going to have a straight line falling upon, making these two angles equal to each other. And as this angle is equal to this one and this one is equal to this one, we are going to have these two being equal to each other. I'm a bit confused. Here we are going to have something like this. As we have here a parallel, two parallels, and we have this one falling upon, we are going to have that this will be equal to this one. This angle will be equal to this angle. And here we are going to have also two parallelograms. We're going to have a line falling upon, and we are going to have this angle being equal to this angle over here. This angle over here. So you're going to have this one being equal to this one, this one being equal to this one, and this one's going to be equal to that one. And as we have this is a parallelogram, we are going to have all the sides equal. We are going to have this a right angle because that one was a right angle. We're going to have all right angles. We're going to have here a square. As well, we are going to have here, this is going to be also a square because it's going to happen the same. Okay, so this is a square and this is a square. Okay, so we have proven already that these two are squares. What do we have left to prove? Okay, let's extend this line. Okay, let's extend it. Sorry. Let's extend it here. And let's draw these down, from this one down. Okay, we're going to have here a right angle, we're going to have our right angles. Okay, so look at these. We are going to have that this is a parallelogram and these two are complements. So we know that they are equal to each other. So now let's do the following. let's add equal to both sides. Let's add this one to both sides. So we are going to have these plus these being equal to these plus these. So we're going to have this equal to this because we added equal to both sides. Okay? So as we have already this one being equal to this one, let's see that we are going to have here two parallelograms, we can say. We are going to have this one and we're going to have this one. Look, they both are in this, they both have same basis because this one is equal to this one because they are the even parts. Okay, those two are equal to each other and they are also in the same parallel. Can you see here? We are in the same parallel. So they are going to be equal to each other. So we're going to have this one being equal to this one. Okay. Now, what are we going to do? Let's add equal to both sides. Okay? So we're going to add this one to both sides. Oh, sorry. We're going to have this one being equal to this one, and as this one is equal to this one, we're going to have two things equal to the same thing, equal to each other. We're going to have two things equal to the same thing being equal to each other. We're going to have this one being equal to this one. What are we going to do? Let's add equal to both sides. Let's add this one to this, and let's add this one to this. What are we going to have? We're going to have this equal to this. Okay? We're going to have then that this equal to this. Now we are going this. Now let's add this last one to both sides. We are going to have this equal to this plus this. But look, this plus this is a square. Is the square on the even part. And this is the rectangle contained by the uneven part. But why? Because this rectangle is we can see it in the right in the origin lines that this is contained by this and this. That is the first part of the uneven part, and this one equal to this one. Why? Because this is a square, all the sides are equal. We're going to have this one equal to this one. So we're going to have this one being the rectangle contained by the uneven parts, and we are going to have what? This square being in the square contained by the side that is in between the points of section. Why? Because this is in the line in between the points of section. So we're going to have, as what we wanted to prove in the beginning, that given a straight line cut in even and uneven parts, the rectangle contained by the uneven parts plus the square on the line that is in between the points of section are going to be equal to the square on the even part. And that's what we have proven here. That was proposition 5 of book 2.